Hello, I'm John Grant, and welcome to the next in a series of conversations the Wardley Mapping Community is recording during the run-up to MapCamp, which will take place in London in October. Before I introduce today's guest, I'm delighted to be joined by Ben Mosior. Hello, Ben.
Hello.
So, we've not spoken for a while, but what's caught your attention recently?
There's always interesting stuff happening in the mapping community, and I've noticed recently, as seems to be the case a lot lately, people are playing with different kinds of ways of visualizing and generating worthy maps. And of course, I'm always a fan of just like pen and paper, just sort of like, I think the digital tools are great when you have constraints. But some people are like building IDEs, like there's something called MapScript. I think it's mapscript.org. And but I've also seen another experiment by Dinis Cruz in the Open Security Summit Slack, where they wrote some serverless code to basically generate maps on the fly from a notation system that you post in a Slack message. And I thought that was just absolutely fantastic. So yeah, that has really caught my eye.
Well, that reminds me, I'd like to make everyone aware that the next version of Atlas is being planned, and there's a lot of activity going on in the GitHub repo. So Atlas is an open source application. It's for creating and sharing maps. The aim is to streamline the map creation process and facilitate collaboration. So we'll make sure there's a link, but if you're interested, get involved. There's quite a few interesting issues in the issue tracker, lots of ideas and suggestions. And I think that links to what you just said there, Ben. You know, pen and paper is useful. Perhaps, hopefully, fingers crossed, a domain-specific language, but a standard GUI interface which can enable multi-user access on different sides of the globe is a must-have, I think. So I'd like to introduce Ruben Berenguel. Thanks for joining us today. The usual question is, tell us a bit about yourself, but also include how you became aware of Wardley maps, if you can remember the first instance.
So I'm a mathematician, although I'm not working as a mathematician. I moved to software engineering not quickly. I mean, I've always liked programming since I was 8. I was writing BASIC. I started maths. I did a PhD in dynamical systems in infinite dimensional spaces, which is as abstract as it gets. And then started working as a software engineer. I moved to data engineering pretty quickly. And I've been working as a consultant for 7, 8 years. For a few years, I was also a bespoke shoemaker, which is kind of fun to explain because it's not really common.
That's awesome.
And so let me think. I found out about Wardley mapping, I think it was 4 months ago. It's pretty recent, in a Hacker News comment about what do you do in your spare time to make money? One of those, I don't know, extra jobs. And there was a mention of topographical business maps. And I was like, that sounds fun because I love maps and historical maps, the mapping of the earth and all that. And I looked up, I ended up in Simon's book, and I watched all the videos he has posted, I think, and started mapping things. And I went from there to, I gave a presentation in the Software Craftsmanship UK a month ago about how it kind of, not blew my mind, but gave rise to possibilities. And I think that's the thing I like the most about mapping in general and Wardley mapping in particular.
Is that the question I've asked a number of people is, what was that aha moment? When did it click? Can you remember anything specific on
I'm not sure when it clicked. I think I started by watching Simon's talk from, I don't know, 2015 or 2016. And when he was in the middle about the chess example that he used to use a few years ago, I was like, huh. And from then it was like, I would have used these a lot years ago if I had known. So it was like, I could have used this tool before to make decisions. And
so situational awareness, the general concept of that, and the OODA loop.
Yeah.
Yeah, the cyclical. Okay. So it is quite early in your career of wardley mapping. But what do you find? Which aspects do you find most interesting or useful at this stage?
I think the most interesting one is the one I tried to focus in the talk. I mentioned that wardley mapping is a way of seeing something usual in a different way, and that enables different possibilities. I mean, the fact that you can map the concepts having an idea of how they are going to evolve in a natural way. So the commoditization of anything, any product, that kind of introduces a, I don't know how to put it in words. That's the problem. That's why I had to write a talk to try to explain what I find kind of fascinating, that it's kind of something new. You can see your business in a different way. You can see the next months in a different way. You can plan for the next couple of years even, which before you couldn't, or it was just like lick your fingers, stick in the air, and wait to see what happens.
You mentioned the possibilities that wardley mapping makes accessible. Tell me a little bit what that's like for you, because I've used mapping before and explained it before in a way where it's sort of a reliable way to create possibilities that you didn't see before. I'm curious how that occurs for you and what it looks like when you map.
In my case, one aspect of mapping I'm trying to kind of work in the next couple of months or years or the rest of my life, it's kind of having an idea of where the technology landscape is going for what I work on as a consultant, what my next job is, and what technology I focus on today on learning. That's my bread and butter. And if I can choose a technology that is on the rise, I win. And if I don't, I may lose. So I think that's the area I want to focus more. I mean, wardley mapping may not be the best for that, but the fact that it exists kind of opened my mind to that idea of technologies evolve, like products, they get commoditized. I mean, some kind of developers are more of a commodity than others. That's bad, that's good, depends on whether you are hiring or you are going to be hired. I'm trying to have my thoughts around that, but it's still really early because it started short time ago.
Ruben, I'm going to put you on the spot here, so let's see what happens. And I'm really intrigued by this. I wonder if you've mapped the space that you work in, data engineering, big data, and if you have, where do you see, or how do you anticipate the future of Python, Go, and Scala and Spark?
Yeah, I have actually.
Can you share any of that then, please?
I think I can share it. Maybe I'll share it as a link because otherwise I could show it on my iPad, I think, which may not be excellent, but it can give
a screen share.
No, I'll just put the screen close by and then I'll share the image. So I did that as an exercise. Don't worry, I'll share the image. The thing is that it's complicated because it's really personal. That's the problem, that in proper wordly mapping, you share it with somebody and you are going to discuss. I don't see how that's going somewhere. I think I'm not sure that's in the going down in popularity. And having it done only myself, it's like I may be living in a bubble. You never know. So how I see this evolving, right now Python is king in the big data world, and actually it may eat up the Spark market share by the existence of Dask, which is a Python cluster-based distributed computation system, similar to Spark, not exactly the same. It's called Dask, D-A-S-K. It's still early. That's the problem.
I felt Go, the programming language, I really do appreciate, and I like what they're trying to do. It's through simplicity. So to try and strip away the complexity is to keep the language as simple as possible. And although some of the development that I'm doing involves Go, it's kind of plateaued at the moment. But Go has become my go-to language. So if I'm doing just a quick import of a file or a few queries and data munging or things, I find it's quite easy to use Go now as a straightforward tool. It's the tool set is simple, easy to install. My concern about Python, and I really like Python as well, is it's not type safe.
Yeah.
But when you start to map these things, and then you start to look at serverless, and you start to look at cloud and how things change, where we're not creating rigid or bulletproof processes anymore. We're creating things which will fire up in response to events. Then you start to think like the notion of software being correct, mathematically correct, possibly isn't that important. It's more about the speed of delivery.
Yep.
So that's when I've mapped the space. I sometimes map it in my head quickly and then put it on paper. I would agree with you. It is kind of unsure. If somebody was to tell you, I believe it's going to go in this direction, I'd say, well, we'll see. We don't know.
I prefer type safety. That's why I write mostly Scala, but I've been writing Python for 12 or 14 years. And I miss type safety, but there are many more Python developers than there are Scala developers and probably Go developers together.
Well, I think it also, when you start to map this, if you see what the route is of a person into data science, is they will probably start with exploratory data science using Python.
Yes.
It's then moving that into production, where it's probably not the right platform.
The thing is that it's becoming better. There's a lot of work going on in the Python world to make sure that you can move from this exploratory code to production code. And that's what it's really, I can imagine that that's going to eat a lot of the type-safe languages. Or at least that's the plan of people that write Python as a...
One of the things I think about, there was a talk that Jay Bloom has given about serverless, and specifically how serverless reduces the size of the individual things that we're having to keep in our heads when we're thinking about it. And in a way, you talk about like type safety, and you talk about sort of risks associated with code and the complexity within code. In a way, serverless sort of reduces the attack or really the design problem surface.
Yeah,
it shrinks it down so that even though we may have like if Python, say, were an inferior language in a technical sense, but it was quicker to adapt to find ways to actually make that better. Then in the context of serverless, where things are contained and smaller, we have less complexity going on, essentially to shoot ourselves in the foot.
Yeah, you can reduce the complexity and then remove that and move it to the system as a whole. Then
yeah,
that's the thing. I mean, that's why I think Python may win, which is not bad. I mean, Python is a fine language. I mean, I have nothing against it. I'm happy with it.
Have you, just to change tack slightly, have you mapped the JVM and the issues around that? So Java is obviously JVM, Scala is JVM, and also Kotlin is JVM. And if we are moving to the cloud, what happens in that scenario?
I haven't done this exercise, which I should have probably. But the thing is that Surprising, I'm really, really, really not into the JVM at all. So, I mean, started Scala because of Spark, and I really like Scala, but it's the only thing in the JVM I touch. But there are a lot of developments in the JVM, like GraalVM, which is a new compiler from Sun that makes it a bit faster and can interact with Python and Go and anything that can be compiled through LLVM. And that can be massive. It's still early. It was released, I think, late last year. And that can change everything. It's still under the works. Let's see. As well, Kotlin, I know a lot of people that love it.
Yes. So we'll move on now and talk about wardley maps and anticipation, thinking in terms of evolution. And I'm interested in the future of work or the future of the professions. And linked to that is lifelong learning. And I know that your background is a PhD in mathematics. Now, the future is automation, robotics, machine intelligence, and that's going to have a huge impact on the professions. Where do you see, or what do you see the impact is going to be on those with qualifications or background in the formal sciences, so mathematics, statistics, etc.?
I think for pure mathematics, it's going to be the same as it is right now. The problem is that it's not a good outcome already. I mean, if you're a pure mathematician, either you're a professor or you're a teacher or you eventually go into industry. I think that may stay the same, but the changes in automation that are going to happen in the next 20 years are going to change everything. I mean, I'm still not sure what's going to happen, but when we have self-driving cars, that's, I mean, I still haven't seen anybody following all the ramifications of the fact that you don't need truck drivers anymore. You don't need car industry anymore because everybody can have any car. That changes metallurgy as well. The whole economy of the world will change if that happens. I think that's so large that it's like, what could happen? In the shorter term, AI in software development, hard science, or well, hard mathematics, statistics, logic even, I think it will stay the same because they are hard to conceptualize for a machine. I mean, theorem provers are still way, way, way too simple to prove complex mathematics.
If you look at it from a if you look back in history, you go back 20, 30 years, when computers started to become commodities, it wasn't microelectronics that was the profession, it was software engineering, it was software that mattered. And I'm wondering whether, obviously machine learning is all based on maths and statistics, and debugging these machine learning models is going to be an art in itself. But I wonder if that's only going to be a small proportion of the industry in the same way as microelectronics is today. But then we've just reached a point where open source hardware is going to become popular and domain-specific languages, just at the point as artificial intelligence has a big impact. So that's why I asked that question, just to get your take or feel on where the formal sciences will be in, say, the next 30 years. If I had my time again, I wouldn't have done computer science. I would have done mathematics. Whether I've got the ability to do it, I don't know, but I see having that has more value than computer science because it changes, it evolves. So what I learned back then is kind of irrelevant now. It's obsolete. Where mathematics isn't, it's valuable, and it's being applied more and more and more to everyday you know, IoT, machine intelligence, cloud, complexity. So, so if I stick on lifelong learning, I asked this question the other day during an interview, but I'll ask it again, see where we go. Which two books have had the biggest impact on you in this field of systems thinking, complexity, big data, mathematics? And if you want to slip in a fictional book as well. But if you were to say to yourself, if you were to go back in time and say, Ruben, read this book sooner than rather than later.
Systems Thinking, actually, the book by Donna Mendes. That one would be the first. That's a really good book.
Yeah, well recommended.
And the second one would be really hard because, I mean, Systems Thinking, I think it has been the best book or the most changing book I've read in the last 5 years, maybe. So it kind of shines a light over previous things I've read. Otherwise, I don't know, because I'd probably go back and tell myself that I should have paid more attention to some fields or some sections of mathematics I didn't pay enough attention, like category theory or some finer points that I ignored because they were boring at the time and now they could have been useful.
It's the story of my life. Yeah,
when you are doing it, it sounds boring, and then it's like, that's useful.
Yeah, I love having a problem to solve. And when I think about Wardley mapping too, it's kind of a high energy activity. It requires you have to burn a lot of calories to think through the different parts of the system and to be motivated to actually, even though you may be inside your own little bubble, sort of mapping things for yourself, it still gives you a greater depth of understanding, at least for what your own position is, as opposed to not having a position and not knowing it. I think that's really interesting. But how do you choose what to invest the time and energy it takes to map something? I think has a lot to do with what problems you're interested in solving. So I'm curious what kind of problems are really like top of mind for you right now, that what questions do you have for the universe? What problems do you want to really think about solving in the near term?
And the near term were easy. I mean, what my next job may be. I mean, that's always maybe not top of mind, but it's always lurking under the surface. For the company I'm working on, how we could improve processes, what could we remove from our systems? I mean, we have as any no longer startup, you have a lot of code that you may not need, and code you run and you don't need, it's waste. So anything we can move to another vendor or whatever. And actually, part of my mapping has been mapping that and discussing it with some stakeholders in the company. I'm not a business person, so it's not like my kind of job, but it's interesting enough that it's a problem that it's complex and good to work on. So I've had a good time discussing that.
Is that a question of like what code to own?
Not yet, because the team I work on, it's so small that you didn't really need to split into really small teams. It's still owned by everybody, more or less. But you can see the divisions of, okay, this blob is moving to a commodity all on itself, and it uses the same kind of data, the same structures. That's probably done by other company, and we can just pay them.
Got it.
So if I've understood, you're looking at legacy and technical debt.
Not really legacy. It's more like, I mean, maybe we could call it legacy, but it's still code that works fine. It's maintained, not old, documented. So for me, legacy is when you have some issue with the code. It's just that maybe there's a vendor that is doing exactly the same and we don't need to maintain it. And if you remove the burden of maintainability, then you can give these resources to something else, new development.
So just to wrap things up then, in the next 12 months in terms of personal development, what would you like to achieve in terms of Wardley mapping? And just to add to that as well, I think you mentioned before that possibly wardley mapping isn't the total solution. Are there any other techniques that you use now or are thinking about using which you think are complementary to wardley mapping? So
I'm still exploring what other options that are not wardley mapping I can find, and I haven't seen a lot, which is surprising. So for now, it's wardley mapping or similar enough that we can call it wardley mapping. Just change the access a bit, and that's fine. I want to get better at mapping companies I work on, industries, concepts, because that's good to be able to do it quickly and reliably and be able to discuss that, because I think it's a super business tool. So on one side, I want to get better. On the other, I want to be able to use it for my kind of personal benefit or to remove problems from myself personally. Which is hard, I mean, but it's a long-term plan.
And if people want to keep in touch, I know you're on Twitter. I'm going to get connected with you there. Do you have a blog?
I have a blog. I would put the link so you can have it on the. Okay. It's mostlymaths.net. I usually write semi-technical, so it's not super technical. And lately, I have only been writing about what I read each week, kind of the overview of new things I've learned. And that's been a long, already enough writing.
Okay, well, many thanks to Ben for joining me today, but a big thank you, Ruben, for sharing your experiences so far and your thoughts and opinions. That's great, so thanks again.
Thanks, Ruben. I really loved learning a lot from you here.
Thanks, John. Thanks, Ben.